Brandon, it's a hold down the whole lot. No, it's probably your barefoot.
All right.
Your socks.
Why are your car keys on your bed?
You have a coat on too, Bridge. We have number 7. This is our last problem. Number 7.
Pretty graded.
We have given an equation that tells us the number of bacteria present after T minutes. So problem A says, find the number of bacteria present after 11 minutes. So we will just plug in 11. So let's all do that. And you should get 11,711 bacteria.
Wait, we plugged 11.
11. It says T is 11 minutes. T is minutes, so we're plugging it in. So 200 second ln 0.37 times 11 equals, and that is what you should come up with. Okay, one more time. 200 second ln 0.37 times 11. That's what you come up with. Okay, Jimmy, are you with us? All right. When, or find when the number of bacteria is double what we started with. Now, look at your equation. How many did we start with? 200. That's our initial value, right? That's your initial value. So we started with 200. So we want to know, when will we have 400? Double? Does that make sense to you? Now, I'm going to solve this algebraically. I could certainly do it graphically. I'm going to do it algebraically. What do I do first? Divide by 200. And that'll be nice, because of course that's just going to be 2. Divide by 200. Now what? ln both sides. Because that will cancel. And then we will simply divide by 0.37. So ln 2 divided by 0.37. Did you get that the number would be double about 1.87 minutes? That was easy enough. All right. Put that away. We are done with it now. Let's go to your notes. We're on the back of page 37. So we're in our notes. Back of page 37. We have problem H. I know we haven't done G, but don't panic. We're going to do H. So we have 400 over 1 plus 95 e to the negative 0.6x equal to 150. So we're on the back of page 37. And we are doing problem H. In our notes, everybody ready? Focus here. So we're going to solve this algebraically. What will I do first if I'm going to solve this algebraically? multiply this over to here. So I'm gonna have 400, and that's gonna be a distributive, equals 150 plus 150 times 95, 14,250 e to the negative 0.6x. So I multiplied this over to here. And distributed the 150. Alright, now what? Subtract 150. Minus 150. Now what? Divide by this big number. Now, it is perfectly okay to leave that fraction. It does reduce for sure, but you don't need to waste time reducing it because your calculator is sitting right there. It's going to help you. So we have 25 over 1425. I will just get rid of those extra zeros. Equals e to the negative 0.6x. Now I can ln both sides. So the natural logarithm of this fraction equals negative 0.6x. And then I'll divide by negative 0.6. So ln, that guy, divided by negative 0.6. And I got x to be 6.738. Double check that and make sure you do too. Royce, did you type this in?
Not yet.
Not yet. I gotta get your calculator out of that. There you go. Charlie, did you type it in?
Yeah.
You did? Okay. I need you to encourage your friend to participate, okay? Michael, did you type it in?
Yeah, I did.
Reagan? We charge our calculators at home, Reagan. When you're working, charging me every time you're in class. You need to have a charged calculator in class. Alright, is this answer look okay to everybody? Alright, I want you to skip down to J. It is almost identical, and I want you and your partner to work on J real quick, and let's see if we can all get the right answer. For problem J, you're gonna do it exactly the way you just did H. Jimmy got negative 9.378.
Yep.
I think he's right. That's what I got.
Me and Alden.
You and Alden together did that great. Good teamwork. Negative 9.378 is the answer to J. All right. Now, I am going to go through problem I with you. Only going to do it, I just want you to see how it's done, how it works out. It will not be a test question. All right, this will not be a test or quiz question, but I want you to see how it works. So first of all, I just changed the problem a little bit. I put 12 in there. So here's the problem. I don't even care if you write it down or not. I do want you paying attention. I did modify the problem. I have a misprint on here. I put a 12 in there. I left that out for. All right. First step. You probably can guess what the first step is. What's the first step? Multiply by 2. And you might be able to guess what the next step is. What do we do with negative exponents? Make them positive. So this is going to be e to the x plus 12 over e to the x equals 8. Right? We don't like negative exponents. Now what do you think we might do? Let's multiply by e to the x so that we don't have a fraction anymore. So e to the x times, we multiply everything by e to the x. Okay. So e to the x times e to the x is e to the x squared. E to the x times e to the x. That's going to cancel. 8 e to the x. Any idea? We weight everything on the same side. So we're going to have e to the x squared minus 8e to the x plus 12 equals 0. Now, this is where things get a little bit, you got to really be thinking outside the box. This is exactly the same as, let's say, a squared minus 8a plus 12. You see that? You have something squared minus 8 of those very same things plus 12 equals 0. And if that were the question right here, if this were what you had, what would you do with that? You could quadratic formula it. You could also do what? A minus 2, a minus 6. And say a is 2 or a is 6. Isn't that how you would solve it? If this were the question, that's how you solve it. But it wasn't the question. Instead of a, didn't we have e to the x? So instead of a equals 2, we have e to the x equals 2. And e to the x equals 6. And then how do you solve that? Now you use your logarithm. Yeah, so you ln both sides. So x equals ln 2, whatever that is. And then x equals ln 6. So the key to doing that problem is right here, recognizing you have a quadratic equation, basically. But your variable is e to the x. Okay? All right, well, I want you to see that even though it's not going to be on your test or quiz. All right, now we're moving on to, no, one more thing. One more thing. not gonna reduce that. I'm giving it to you upside down because I wanna run through this last page is an old quiz. I wanna run through that before we start. Alright, so a little bit of review here before we start our word problems. So on the very back, old quiz says period 5 is awesome. Old quiz.
Thank you.
Well, you're period 3, but I love you too, you're awesome. Alright, so here we go. Solve the following. This is review. Please pay attention. What do we do first? Erica? Oh, come on.
Oh, you multiply them?
Exactly. You cannot do this problem, you guys. This is not good. So we're going to put those together into one logarithm. These two get condensed into one logarithm. And Erica said they go together as a multiplication because that's an add. So when I put these together, it's going to be 5x minus 10. I'm going to multiply these things. Remember that? Lord, I hope so. We already did this. This is review. We've done this. Now what do I do? Loop-de-loop. That's exactly right, Mike. Loop-de-loop. So 4 to the second equals 5x minus 10. 16 equals 5x minus 10. 26 equals 5x. And x equals 26. So, two things you gotta remember. First thing you gotta remember is, this can't be. They've got to go together and make one logarithm. As soon as you do that, you have to remember you're going to loop-de-loop. And then it's just solving. All right, number 2 looks a lot like that. What is the first thing we're going to do in this problem? These are going to go together into one logarithm. Now, when these go together, these guys are going to go together as a division. So this is going to be x plus 1 over 8. Now, that problem looks different than this one because this one had a plain number on one side. This one has another logarithm on the other side. But what are you allowed to do? Now you can get rid of them and solve the resulting equation. So does everybody see the difference between this equation and this one? When there's only one logarithm, you loop-de-loop. When there's a logarithm on each side, you do each other. one of your properties. Number 4. The answer is square root of 5. It's 5 to the 1/2, right? You can do it. 5 to the 1/2, which is the same as the square root of 5. How about 5? Number 5. X squared equals 16. So x is 4. 6. Be careful. What are you going to have to do first with number 6? What is that? That's an exponent. That is an exponent. So this is the log of 16 plus the log of x equals 1. Now, can you do this? Not without making them into line.
So log.
Log. What am I going to do with these numbers? Multiply. So log 16x. And I want to loop-de-loo, but something's missing. This is 10. So 10 to the first equals 16x. 10 to the first is just 10. Divided by 16, it looks like x equals 5x. ln is the symbol for, well, yes, that is a natural log. It's log AC. That's what it is. Now, do not lose this. This is your review sheet, so please do not lose it. Hang on to it. We have one more thing to talk about now, and it is the word problems. So 3-6 is all about word problems. 3-5, have I assigned that yet?
Do tomorrow.
Yeah, I thought I assigned that. Yeah, 3-5's tomorrow. Now,
Hold on, by the way.
there are a bunch, not a bunch,
Hold on, by the way.
4 formulas that you need to be aware of. 2 of them you will need to memorize, the other 2 you won't. So there's 2 formulas that we are working with today. These are your growth formulas. Growth formulas. 2 of them you need to have memorized, and you may already have them memorized because you did them last year. One of them we call our PERT formula, and this is the formula for continuous growth. We're going to talk about what all those letters mean in a minute. But if your problem contains the word continuous, you will use that formula. No matter what kind of problem it is, if it contains the word continuous, that's the formula you're going to use. You will also use this formula for any natural growth problems. And what we mean by natural growth is like a bacteria population. The problem we just did earlier, where we had a bacteria population, and that formula was a version of this. Okay, so anything from nature, you're going to use this formula for. Okay? Now, in the formula, this stands for what you end with, the amount that you end with. P stands for the amount that start with. E is E, right? E is a constant, it's not a variable. We don't plug in anything for E, it's in your calculator. R is your growth rate. And you're gonna enter it always as a decimal. So if the problem says 6%, you won't put in 6, you'll put in 0.06, and T is time. And in this formula, time can have any unit. So in other words, you can do this formula with months, days, hours, weeks, decades, whatever. The other growth formula that you have to memorize, these are the only two. All the other ones I will give you, but you need to memorize this one. This is your compound interest formula. It is only used with money. Only. So if you're talking about a bacteria population, you will never be using that formula. If you're talking about your bank account, interest compounded monthly, you'll be using that formula. Okay, got it?
Got it.
All right. Again, A is what we end with, P is what we start with. This is the number 1. It's not an L, it's not a variable, it's a 1. Here's your interest rate. And again, it will go in as a decimal. N appears twice in this formula, and like always, if the same letter occurs more than once in the formula, it has the same meaning. N is one thing, it goes in twice. And N is the number of times per year that you compound. So remember, this is a money formula, so growing. Money growing in bank. So your interest compounded monthly, N would be 12. Yearly, N would be what? Quarterly, N would be 4. Get it? That's what N is. And then T is the number of years. So in this formula, T can be anything. Days, minutes. But in that formula, T is always years. It's NT. Yes. All right, let's take a look at our problems. Page 38 of our notes. You have these written down. I guess I can put them up there. I saw this. All right, here we go. Number 1. How long will it take for an investment of $1,000 to double if the bank pays 2.5% interest compounded quarterly? Okay, step 1. Figure out which formula you're going to use. That one. What's the key? Compounded quarterly. That's that formula. So how long will it take for an investment of $1,000 to double? Okay. So what? I heard somebody get ready to say something. I'm starting with 1,000. And it's going to double, so it's going to equal 2,000, end up at 2,000. 1 plus my interest rate is 0.025. Compounded quarterly, so N is 4. And I don't know how long. So T is my variable. Would you agree ya? Alright, what a mess. We gotta solve this guy. What do you wanna do first? Divide by 1,000. Absolutely, we're gonna divide by 1,000. Okay, now, he wants to go ahead and calculate this, and I think this one's gonna be okay. We never want to round off within the problem. I think that one will work. Let's see. 1 plus 0.025 divided by 4. So that is 1.00625. But remember, don't do that if it means rounding off. Like if this has been divided by 3, don't do it. Because you can't round off in the middle of the problem. It throws off your final answer. And you got a $100 calculator, you don't need to round it off. You can type in that expression, you don't need to round it off. But it's okay this time. It's okay, because it worked out in the other. Alright, now what? Well, how do I get 4t by itself? I can't get 4t by itself because it's an exponent.
Oh,
So we need to take the.
I need to take the logarithm of both sides so that that exponent
Comes in front of the.
comes out in front.
And then we can just divide by the log of 1.2.
Alright, everybody follow that? So you knew you needed to get that 4t by itself. Problem is, it's an exponent. So the only way to do that is the log, because then it comes down and now it's solvable. Now I can solve it. Okay. I want to get t by itself. So we need to divide by the log of this thing. Okay.
This has 2 zeros.
Alright. I think I left this in. That would make a difference, thank you. So I'm gonna have the log of 2 divided by the log of that thing. And then, remember, that wouldn't be t, that would be 4t, so after I get that guy, I have to divide by 4. And I got 27.81 years. Remember, time in this formula is always years. Okay, number 2. First thing you do is figure out which formula you're going to need. Which formula, how much will be in the account at the end of 10 years if this much is invested at this rate, compounded monthly? Same one? Same one. How much if I start with this much the 120th power. $1,680.53. That was easy. Number 3. How long will it take for a population of 450 geosites to double if their growth constant is 0.123? Which formula? PERT. This is a PERT. Geosites are some kind of organism. Right, so population certainly isn't money. Remember, this formula is used for compound interest. This is not a compound interest problem. So it's got to be PERT. How long will it take for a population of 450 to double? So I'm starting with 450, ending with 900. Their growth constant is 0.123, and I want to know how long it takes. Okay, step 1. Divide by 450, and that of course is going to give me 2. Now look where your variable is. It's up in that exponent, right? We just talked about it. If your variable's up there, you can't solve it. You gotta get it down. How do you get it down? You log. In this case, I'll ln. I could log. Easier to ln. So ln2 equals 0.123t. So t equals whatever ln2 divided by 0.123 is. 5.635. And I was not careful in my problem. I didn't tell you, so I'm just going to say days. You can say months, you can say weeks. It's something. There's some time unit. I needed to tell you that, and I didn't in the problem. But it's a time. So it's got something, minutes, hours, years, whatever. Problem 4. How much do I need to deposit in an account paying 4% interest compounded continuously if I want to have 35,000 in 10 years? Which formula? Okay, I want you to look back at your notes. If you wrote down what I told you, I told you this is the formula we use if the problem contains the word continuously. As soon as you see that word continuously, it's a verb. Regardless of whether it's money or not. So this is a PERT problem. How much do I need to deposit? 4%, 10 years, if I want to end up with 35,000. So look at that carefully. Does that look like which one on? I want to know what P equals. First, I'm going to make that a 0.4. How am I going to get P by itself? I'm going to divide, not by P, I'm going to divide by either 0.4, aren't I? Notice I'm not using logarithms. When do I use logarithms? When my variable is the exponent decay constant of an element if its half-life is 10.2 years.
You gotta do the first one.
Now, do this one for sure. Now, think about this for a second. You know what half-life is, right? What's half-life? Half-life is the amount of time it takes for half of it to be gone. So in other words, half-life would be how long it takes to get from 8 to 4 or from 12 to 6. Well, do I know how much I'm starting with here?
No, but we can figure it out. It's just 10.4.
I don't need to know how much I'm starting with. I just need to know I'm ending with half of it.
Yeah.
So let's start, I don't know, let's start with 10, and then we end up with 5. If you don't like those numbers, you can start with 12 and end up with 6, or start with 20 and end up with 10. It isn't gonna make a difference, you'll see here in a block. Pick a number, that's how much I'm starting with. I have to end up with half of it. I don't know what my R is, but I know my time is 10.2. Would you agree with that? Now, here's why it didn't matter. Let's say we wanted to use 20. Why isn't it gonna matter whether you start with 10 and end up with 5, or start with 20 and end up with 10?
Divide.
First step is to divide, right? And what's gonna happen every time you divide? You're gonna end up with a half equal to e to the 10.2r. So pick a number. If they don't tell you what you're starting with, pick a number and then end up with half of it. Where's that exponent? Oh shoot. Where's that variable? It's in the exponent, which means I'm going to need logarithms, right? So I'll ln. So ln 0.5 equals 10.2r. ln 0.5 divided by 10.2. Whoa, whoa, whoa. Negative 0.068. Did you get that? Tell me about that negative R value. What is the R?
Oh, it's decay.
Exactly. R is your growth rate. If you're going from 10 to 5, you're not growing, you are decaying, and decay is negative growth. So it makes perfectly good sense. Now, if this is a money problem, you do not want to see that, because that would mean you are losing money. All right, number 6, try it on your own. Number 6, you and your program. Figure out which formula you're using. Plug the numbers in. 3.180. And again, I messed this up. I didn't give you any time reference, but this would be days or weeks or months. There's a unit attached to this, and I should have provided that unit in the problem, and I didn't. But it does, it's really not, but it is what it is. All right, let's see if we can get the last two on this page, and I'll do the harder ones tomorrow. Number 7. Which formula for number 7? The big one, compounded monthly. So how much will I have in my account if I start with 555, 0.035 compounded monthly for 12 years? Does that look like what it should look like? And I'm gonna go ahead and make that a 144, make my life a little easier. Am I gonna be using logarithms or anything fancy here? No, A's already by itself, so I'm just gonna type it in. 555, parentheses, 1 plus 0.035 divided by 12, close parentheses, raised to the 144. I got $844.17. Last one. Which formula for the last one? Right here. Because in the problem I see compounded continuously. So I want to end up with 1,000. I start with 890. I don't know the interest rate, but I know the time is 3. Step 1. Divide by 890. So divide by 890. We have 100 over 8,900. Go ahead and cancel those zeros. You do not have to. Equals e to the 3r. Notice my variable is the exponent, so you have to use logarithms. What interest rate? I got 0.0388, so I'm going to say 3.88% is the interest rate that would be necessary. Do you agree with that?
Yeah.
Okay. All right. Tomorrow we'll do a little bit of review and continue on here, and then our next class, whenever that is, we are going to have a quiz like we practiced today, kind of review type quiz.